Good afternoon to all, and thanks for the invite to speak at this Raute event. My name is Inka Orko, and I come from VTT Technical Research Center of Finland. I'd like to briefly just say a few words about where I come from. So VTT is a multidisciplinary research and technology organization. We are located in Finland, and we operate as a limited liability company, but we are a not-for-profit and fully owned by the government of Finland. Our brand promise is to always think beyond the obvious. It's a promise to take on the world's biggest challenges and to solve them by developing technology-based solutions. And we work in collaboration with our customers and R&D partners. Here are some numbers from last year. So VTT's operating income was a little bit short of 300 million euros, which comes from confidential customer work, competitive research funding instruments, and then some 1/3 of it we get from the government, and we spend it towards new blue sky technology exploration. In 2023, we had a total of 1,135 employee customers, and our domestic income accounted for about 55% of the revenue. At the end of 2023, VTT had almost 2,400 employees, and we represent more than 50 different nationalities. We promote scientific publications, and we produced almost 500 different scientific articles last year. But another way for creating impact is via patents and IPR, and we have our own incubator for spin-offs, and we already have about 50 spin-offs that have taken off since 20 years. We operate in 3 different business areas, the carbon neutral solutions, digital technologies, and sustainable products and materials. Personally, I come from the sustainable products and materials area. However, as we know, the industries are blurring, and we also collaborate tightly with our colleagues in the other business areas. So let's move to the topic of today. So let's first discuss the landscape, just so that we're on the same page when we talk about circularity. Then I'm going to present 3 hypotheses for implementation of circularity, and that comes from the corporate perspective. And then I'm going to give just a few examples for circular veneers. So why do we need circular economy? You may be familiar with this graph. It's by the Circle Economy Foundation. And since 2019, they've been publishing this Circularity Gap report. This graph shows the material consumption development in gigatons since the 1900s. We see that this curve is on an exponential growth. So it's been on the rise, especially from the 1960s. The red number at the very end of the curve represents or shows the percentage of material that's being reused. So unfortunately, the circularity rate is developing towards the wrong direction in the global scale. There's a drop from the year before last, from the 8.6 to the 7.2 from the end of last year, and a drop of more than 20% since 5 years since the beginning of this reporting. However, the good news is that the importance of circular economy has been understood and widely recognized, and there are many initiatives already in local communities at the national level, but also at the EU level, for example, in the regulation. So we all know about the Green Deal and the ESPR and other drivers that are incentivizing circular economy, making it gradually a compliance issue. And of course, there's also reporting, CSRD, etc., that are kicking in. In Europe, the situation is slightly better than globally. So on the left-hand side, we see the materials in the Sankey diagram of the natural resources intake that we bring into the system and import to Europe. It's followed by the materials processing and then manufacturing of the products from that material. We see that there's also the formation of waste in emissions and also in solid waste. On the whole, the circular material use rate was 11.5 in Europe, which means that that percentage of material resources used in Europe came from recycled waste materials. Now we can take a closer look at this diagram, so we can see that the biomaterials eventually mostly end up in the emissions. Of course, there's some buildup in the reserves, but also very little recycling back into the loops. And of course, much of the biomaterials we use for disposable and single-use products, so that's part of the equation. But I'd still like you to remember these numbers for later on when we take a better look at the biomass products. On the whole, I think there's a lot of improvement and opportunity in there. So I'll show the examples a little bit later on. To summarize these two graphs, our global material demand is on the growth. Our material resources are diminishing, and at the same time, we are producing emissions and waste problems, and we are carving a hole into our biodiversity. So it's clear to me that something needs to change in the current system so that we get it working again. And it's also clear that no industry can get a free ride to be excluded from these circular economy actions. And by the way, we also do think that circularity can be good business. This is a little bit of a deep dive into the regulation. So we know about the ESPR, the Eco Design for Sustainable Product Regulation. It entered into force July 18th this year. And it has two different sides to it. So the other one is about regulating the products themselves. So there needs to be certain designs that allow for durability, that allow for repairing, etc. And then the other side of the regulation is about information and, for example, the digital product passports. The regulation in itself is general, so it means that there will be some supplementing delegated acts that will be worked on starting now. So if you are interested, please go ahead and join the groups, because in the groups we will be deciding what kind of specific parameters will be included in the digital product passport, for example. Beyond the regulation, another important and maybe even more influential driver is, of course, the material prices. So I don't have the exact price for lumber or timber at the moment, but there is a fluctuation there, of course. But since last I looked, for example, birch had gone up 30% in the last 4 years. And there's a direct link to the price of feed and raw material to where the companies direct their development efforts and innovation funding. And of course, that also determines what raw materials and products succeed in the market. It may incentivize also the product designers to use more side streams in the products. Since we talked about construction or mentioned it earlier, I'll just briefly say that the revised CPR, that's the Construction Products Regulation, has just come out. So I picked this out from the internet just 2 days ago. It will harmonize the performance parameters for the construction products, and it touches on the digital product passport as well. So the idea is to harmonize between the ESPR and this particular regulation. And of course, the reason being that we know that housing and building really play an important role in both the material use. It accounts for 50%, and then also in the energy consumption and waste creation. So this is an important industry. And this is also, as it's a challenge, it's also an opportunity. So I think the industry can really have a significant role in how these numbers will look in the future. So now I'm going to my hypothesis. I said I'd present 3, so this is the first one. Climate change mitigation, always important, of course, and a major factor already in most industries. However, we're often focusing just on that, and we think that that's not enough. we need a more holistic approach across the value chain and the product life cycle to solve the issues which I saw in the curves. There's probably no veneer that's been used in electric cars, but I'm still going to use this as my example because it works well in that. So we, of course, often think that electric cars must be very sustainable. They are good for the environment. However, if we now take a closer look at the value chain for the electric car, we can see that we're only halfway there, if not even that. So the cars are still manufactured and used in the linear value chain. In the middle, we see the traditional value chain. We typically take some virgin materials or sometimes even recycled material. We process it. We manufacture the components. We assemble the car, and then we sell the cars for use and we drive them. And then until that point, we dispose of them and we crush them, and some of the material is returned back to the cycle. So we are really not operating in the circular economy fully, even though the use stage of the car may be more sustainable after some years, and depending on how we produce the electricity. So how do we move to a fully circular value chain? Our thinking is that we need to design the car for a circular and sustainable life cycle, even if our current business boundaries ends when the car is sold to the customer or the user. We talk about implementing the R cycle, so that means the refuse, which means that if we can live without it, we will. But if this is not possible, then reduce the amount of materials, reduce the weight, then reuse the product, reuse the material, and then repair our product if we can and return it back to use. And then only after that, the recycling. So nowadays, we see the green bubble there in the picture. So that's the recycling bubble. So oftentimes nowadays, we do consider recycling, and it's often part of the value chains already. But this is just one single action towards circular economy. And we have to look beyond that. So to really transform to circular operations, we want to activate the yellow bubbles as well, and the business models that they represent. If you look at the individual raw materials from the beginning of the value chain, can we design the car so that the raw materials have a higher content of recycled material, for example? Or can we design the car so that it's longer in use, so that it's more durable, so that it's modular, it's repairable, the maintenance is easy? Can we also make the car lighter so that we will save both in material and in the energy consumption during the life cycle? And also, can we collaborate with other stakeholders to enable all of this and to extend the life cycle? All in all, in addition to the technology that needs to be developed to get all this working, we need to activate also co-development, collaboration, and business models to support the R cycles to the full. So how would the holistic operation look if we were looking at the veneer production? So I borrowed here a picture from Raute website, so thank you for that. It's usually a good idea, and I think it says also in all of the textbooks, that you should start with the customer. So it would be a good idea to start with the whole with the use point in this value chain. So if we take a look at the very beginning or the very use cycle, then who are the users? How are they using the product? Can we maybe implement some measures there to make the product last for longer and remain in the use cycle for a longer time? If we look at the beginning of the cycle, then what are the material inputs? So is it possible to replace some of the raw material with circulated or recycled raw material? Are there some side streams that we could utilize when we manufacture? Are we looking at the energy efficiency closely enough? So is there a way to save energy? Can we apply renewable energy sources in manufacturing and actually throughout the whole value chain? Then For example, when we talk about veneers, of course, sustainable and bio-based adhesives have been on the agenda for a long time, as well as sustainable sourcing of raw materials, looking at the forests and logs as well. Then one important factor is the data. So in order to make all of this work, we need to understand the data and interpret it into information, and we need to be able to share the information between the different operators in the value chain. There's plenty we can do, and of course, all of this needs to be implemented through our product strategy as well. My second hypothesis. So we said earlier that we should ideally consider the use case and the customer need, and then design the products within the circular economy principles. But to do all that, it's not very easy, of course, because the choices we make don't necessarily always lead simultaneously to the preferred direction, considering business, considering sustainability impacts, considering the market. So it also depends a lot on what our business is and where it's geographically located and what the business environment is. We may have invested into our processes. We may not be able to change our processes directly. There are also some conventions in the industry and with our customers. So can we push through our new products and concepts? We may need to train our customers to do that. So all in all, it's not straightforward, and there are trade-offs, and there are pros and there are cons. Nevertheless, it always pays off to make sure that we base our choices on relevant information and meaningful viewpoints. And that's why it's important to understand the whole of the value chain. Let's assume we're developing a material with superior performance by adding, let's say, a thick plastic barrier layer on the surface of the board. The lifetime may now be twice the earlier version of the product, but what about the recycling? We cannot grind the material anymore, we cannot reuse it because the plastic is there, or we may be able to do that, but it takes a lot more energy. Which is better then? Well, as a rule of thumb, we typically say that it's more beneficial to continue the life cycle of the product, but it's not always true. And that's why it's important to understand the use case and to understand the details. Another typical situation that we hit is that we believe that by making our products repairable or more durable, we're cutting off our own supply or demand, and we are shifting business opportunities to somebody else, to the recycled products market. But if we think more closely, maybe we're instead enabling growth in our market, and maybe we can consider even product as a service or deposit models or partnerships so that we can find other means of making the revenue. A third bottleneck may lie in the side stream utilization. Bark, for example, might be used as a replacement for virgin wood material in some applications. However, as it's considered a low-value side stream, the availability is not always there. Also, it may not be homogeneous if we have to source it from different sources. And that's why partnerships, collaboration, process adjustments may be needed together with our partners. I like this black picture on the right because it shows the different ways of measuring material circularity. So we may have different perspectives when we develop our circularity strategy. There are several indicators, such as the material efficiency ratio. There's another indicator, material circularity indicator, and then the carbon intensity. So these all may lead to a little bit different conclusions when we do the math. We may also decide to use different LCA tools to attach our targets for circularity. But whichever way we decide to go, it's important to have these metrics and the monitoring in place so that we know where we are going and that we are not going the other way. My third hypothesis comes here, and it's the last one. So it is that circular economy or sustainability is a comprehensive way of thinking and operating in a company. We cannot go fully circular if we don't integrate the principles through the functions within the company. So it means that we cannot put post-its after we have done the operation and then just hope that things will work. I think there's an analogy here to work safety and how we need to really push through the thinking through the organization. This is my circularity onion, so I'll try to explain what I mean just by what I just said. So this picture is drawn from the point of view of a company. At the very core, in the darkest green, we have the products, and this is the core of the company. So it includes also the raw materials, our sustainable product designs, our product services like maintenance, spare parts. It should also include a concept for the end of life practices for our sustainable product. Also, much of the regulation concerns the products, and also this is what the customers buy from us. So this is the basic stuff. The next layer in this onion is the circular business operation. So not everything can be controlled or monitored or run through the product line. So the second layer includes the circular business considerations for the whole of the company. We need to have the circular economy in the strategy, and we need to have it also in the business models. We have to look at manufacturing across the product lines. We have to look at the energy use, the energy sources. We have to look at the sustainability reporting. We need monitoring programs. We need follow-up and development activities that run across the organization so that everything is in synchrone. We also have to make the agreements and build up the partnerships with our collaborators to continue the use life. And these need to be corporate or company level actions. We also have to make sure our people have the required tools and the knowledge and competencies to carry out our roadmap to circularity. Our third layer, the circular value chains, is very important in circular economy. So we cannot just close that off and think that it doesn't concern us, because circular economy cannot be carried out alone. We always need the partners to make the shift, whether it's a big or small change, and collaboration is something we really need for that. It's a powerful tool for a circular economy also if we take in the co-creation activities. We can also then find new models for value creation and value sharing that aren't necessarily the traditional ones. So as a summary, circular economy is not just about reducing carbon footprint, but activating the R cycles of reduce, reuse, recycle, etc. So for that, we need to understand the sustainability and markets through the value chain and then aim for a holistic solution. Here come a few examples from VTT regarding circular veneer and plywood. So VTT has been working with wood materials and lignin and fibers for about 80 years. And we have the IP and we have lab to pilot capabilities, both in fiber side and also the biochemicals from wood. And one of the challenges that we've been solving for the past years has been how to replace fossil-based adhesives with bio-based and recyclable adhesives. And here are a few examples of the functionalized polyphenols that we've been developing for adhesives for plywood and particle wood, or particle board, sorry, and also the MDF. We also have some coating formulations for wood, and then functionalized polyphenols that work as preservatives and flame retardants in wood. This is the one of the adhesives and compositions that we've been working on. We derive it from wood bark, and the right-hand side shows the test joints for birch veneer and plywood with that adhesive. This is another example of a project called Inka, where we are developing technology, but also looking at how to make the products fit the market. This is an EU project, and you can see our partners there. So it's an international project with partners, for example, from Spain and from Greece. The technical focus in this project is that we are defibrillating plywood waste streams, and then using our IP and very technological solutions to that's including also biotech. So we have biotechnical laboratories as well. So to manufacture innovative board applications, for example, for insulation and for growth media. So to conclude, we believe that circular economy is a long-lasting transformation, and it's not going to go away very soon. And we encourage all stakeholders to think through what we can do and what it can mean in business and also in the practical operations. I'll conclude my presentation here. Thank you for listening, and I hope I can connect with you on these or some other topical items. Thank you.